continue from where we left off last week. Last week we have learned about uh, combining functions by some difference products and quotients, where we have also uh, learned about this example, and also we have tried this challenge. Now we are going to the composite functions. So we can also combine functions by composite. What does it mean by composite? So suppose that we have f and g to be functions. The composite functions f og, so f circle g, meaning that f is composed with g, is basically this expression. Okay? F circle g of x is f of g of x. So now, what is the domain of the composed function? The domain of this composition function is that the domain of G where the range of G is part of the domain of F. So the domain of F composed with G consists of the numbers x in the domain of G, which Gx or the range of G lies in the domain of F. Okay. The important part of this composition function is that you have to make sure you have to take a note. You have to pay attention to the composition function because f composed with g and g composed with f are in general quite different. So in general they are not the same. So we cannot simply flip the position of f and g in this case. For example, if we have f of x is square root of x and g of x is x plus 1, we want to find f composed with g, g composed with f, f composed with f, and g composed with g. First, f composed with g, meaning that we have f of g of x, meaning that now we have square root of gx instead of square root of x, because f of x is square root of x, then f of gx is square root of gx. And now we can substitute this gx as x plus 1, because g of x is x plus 1. So f composed with g is square root of x plus 1. In this case, the domain now becomes from -1 to infinity. Why? Because of this, basically. So we have f of x equals to square root of x. In this case, the domain of f is, anyone remember the domain of f? What is the domain of f in this case? What is the domain of f? From 0 to infinity. Okay. And the range of f. What is the range of f? Anyone remember? What is the range of f?
0 to infinity.
Also 0 to infinity, correct. Now we have g of x equals x plus 1. And in this case, what is the domain of g? And what is the range of G? What is the domain of G for this case?
Minus infinite to infinite, sir.
Yeah, correct. Minus infinity to infinity. And what is the range of G? What is the range of G?
Mean infinite to infinite also,
Yeah,
sir.
also minus infinity to infinity. Correct. Now, we want to construct f composed with G, yeah, of x. Then in this case, the domain of f composed with G is basically, okay, let's take a look at this. The domain of G is basically from minus infinity to infinity. And let's say this is 0 and this is minus 1. This is the domain of G. And the range of G is also from minus infinity to infinity. The range of G. And let's take a note here, 0. And okay, if we take x to be minus 1, then what is the value of Gx? G of minus 1 is
0.
0. Okay, then let's make this mapping. So minus 1 is mapped to 0 and 0 is mapped to 1 and so on. So it should be like this. Now, because we want to compose f with G, so f composed with G, what is the domain of f composed with G? We need to take a look at the domain of f. Now, the domain of f is, okay, let's take the blue one. From, okay. The domain of f is only from 0 to infinity. Okay. So we have the domain of f is only from 0 to infinity. So now to construct the domain of f composed with G, we need to take a look at the domain of G for which the range of G is included in the domain of f. So now let's cut it up to this point. So because the domain of f is from 0 to infinity, so we only need to take the domain, the range of G from 0 to infinity. So let's say we don't care about this part, about the left part, the negative part. Now, let's see. What is the domain of G that makes the range of G from 0 to infinity? What is the range of G that is mapped from the domain of G? Sorry, let me rephrase it. What is the domain of G such that the range of G goes from 0 to infinity? Now we see that it is shifted to the right, right? Meaning that the domain of G, so that the range so that the range starts from 0 to infinity, is actually from minus 1 to infinity, correct? Understood up to this point? Hello.
I'm sorry, sir.
Yeah.
But when you explain the function of f, I'm going to toilet, sir. So I don't know why that domain and range become 0 to infinity.
Okay. This is for this part, f of x equals to square root of x. The domain is from 0 to infinity, and the range is from 0 to infinity. You need to take a look at the materials from last week. So I don't want to explain it again here. But basically, the domain, what is the domain? Domain is actually, in this case, an interval for which the function is defined. So that's if we take negative x, we don't have square root of negative x. That's why the domain is only from 0 to infinity. In that case, the range also from 0 to infinity. So to be more precise, you need to take a look into the last week material.
Yeah, I see. Thank you, sir.
Anyway, okay. So in this case, we have that the domain of f is from 0 to infinity. So we need to only take the range of g from 0 to infinity. So the domain of g such that g of x is from 0 to infinity is actually only from -1 to infinity. In this case, the domain of f composed with g is now from -1 to infinity. It's not minus infinity to infinity. It is also not from 0 to infinity. Understood? Okay. For the next example, we have g composed with f. Take a look, pay attention here that f composed with g, we have square root of x plus 1. G composed with f is different. It is very, very, very different because we have square root of x plus 1. So before, the x plus 1 is inside the square root. Now only x is inside the square root, plus 1 is outside the square root. So we have a very different form of g of x, g composed with x, and f composed with g and g composed with f. They are very different in this case. And the domain, how to construct the domain, you can take a look at this illustration, how to construct the domain of g of x. But for now, believe me that the domain of g of x is from 0 to infinity. Why? Basically because the square root of x is defined only from 0 to infinity. What about f composed with f or g composed with g? In this case, even if you flip the position, because they are both the same, f and f, g and g, we will always have the same form of the composition. But how to construct the domain, you can take a look at this. Basically, since the range of square root of x is from 0 to infinity, meaning that we can use all the domain of f. G of g, g composed with g. Now the domain still the same because it is x plus 2 is defined over the whole real numbers. Okay, challenge. If f of x is x plus 5 and g of x is x squared minus 3, what is f of g, f composed with g at 0? So let me write it here. So f of x is x plus 5. plus 5. G of x is x squared minus 3. Now, what is f composed with g of 0? For this first question, I will give you the hint. Sorry, the hint. I will give you the solution. So we have f of g of 0, meaning that we have f of 0 squared minus 3, because this is g of 0. Then we have f of minus 3. It is minus 3 plus 5 equals to 2. Now, for the second one, what is the value of g composed with f of 0? What is g composed with f of 0?
22, sir.
22. Okay, let's check together. Let's inspect it together. We have g of f of 0. That's why in here we have g of 0 plus 5, g of 5, meaning that we have 5 squared minus 3 is 25 minus 3, which is equals to 22. Then that is correct. Okay, now what is f of f composed with g of x? What is f composed with g of x?
Sorry, sir. In my opinion, pakai bahasa Indonesia, sir.
Yep.
Dalam kurung x kuadrat kurang 3 tutup kurung tambah 5.
Okay. X squared minus 3 plus 5, like this.
Yes, sir.
Okay, this should be correct. Then we have x squared plus 2, basically, right? Okay, if any one of you don't believe me or him, you can check it by yourself. This is our answer. You can construct this in the same way as the answer of A and B. Now, what about G composed with f of x?
Dalam kurung x tambah 5 tutup kurung pangkat 2 kurang 3.
Okay. So, or we have x squared plus 10x plus 22. Yeah. Okay, so this composition is still easy. You can try to do the rest by yourself. Let me skip this one then. Now, this is the tricky part of this material, is how we can draw a function, how we can graph a function by simply shifting the graph or scaling or reflecting the graph of the basic function. Like, okay, if we have the function y equals to f of x plus k, so the basic function is as f of x, and now we shift it by k, so we plus k. In this case, it means that if the if k is positive, we shift the graph up by k unit, and if k is negative, we shift the graph down by absolute k unit. So if we have the plus some constant outside the function, meaning that we shift the graph vertically. But if we add the constant to the independent variable x, in this case, we shift the graph horizontally. But now the difference is that if the value of h is positive, the graph is shifted to the left, and if the graph the value of h is negative, the graph is shifted to the right. For example, now if we have y equals x squared, let's see, where's my here. If we have f of x equals x squared, if we add plus 1, the graph of x squared shift up by 1 unit, and if we add minus 2, the graph of x squared is shifted down by 2 units. We can see in this example, you can see from this example that, okay, we have the graph of x squared is the blue graph, and if we add plus 1, the graph is shifted up by 1 unit, and if we add minus 2, the graph is shifted down by 2 units. The shape of the graph are the same. It's just the graph is either shifted up or shifted down. Now, if we add the constant to x instead of to y of x, so let's say from y equals x squared to y equals x plus t plus 3 squared, or from minus this graph, for example, from y equals absolute of x to y equals absolute of x minus 2. Let's take a look at this example. I will illustrate only shifting f of x equals to x squared from to the left or to the right. If we add plus 1, the graph is shifted by 1 unit to the left. If we add minus 2, the graph is shifted by 2 units to the right. So up to this point, any question? Any question? Any question? No?
I think no, sir.
Nothing, sir.
Now, what is the equation of the red graph? So the blue graph is y equals x squared. Now, what is the red graph?
Y equal to x squared plus 3.
Yes, correct. And what is the equation for the yellow graph?
Y equal to x squared minus 5.
Yeah. This one, this one is still easy enough, right? Now, this one is a little bit more complicated. What is, which pair that is correct? For example, let's take a look at the first equation. Y equals x minus 1 squared plus 4, minus 4. So in this case, we have x minus 1 squared. So basically, we have y equals to x squared. Now the x is, we add minus 1 to x, meaning that we shift the graph to left or right by 1 unit. To the left or to the right? If we
Right,
add
sir.
to the right, meaning that we try to find the graph that is shifted to the right by 1 unit. Now we add minus 4 to the squared, meaning that we shift the graph where up or down or left or right in this case.
Down, sir.
Down by
-4.
by 4 unit. In that case, what is the correct graph for A? The blue one, red one, yellow one, or green one?
Green one.
The green one. Now, what is the correct graph for B? We already have A is the green one. So B, which one? The blue one, red one, or yellow one?
Blue one.
The blue one. Why? Why the blue one? Why the blue one? You can explain in bahasa if you want. Why the blue one?
Karena itu X min 2, sir. Jadi ke kanan.
Okay.
Terus plus 2 jadi naik vertikal.
Yeah, that's correct. Now, what about the equation C? The red one or yellow one?
Red.
Red one. And D is the yellow one. So any one of you still don't understand this, you can ask your friend. Let me continue to the next material, which is about scaling and reflecting a graph of a function. If we have C greater than or greater than 1, it's not equal to 1, right? So if we have C greater than 1, the graph is scaled by, okay, if we multiply C to the value of fx, meaning that we stretch the graph vertically by a factor of C. And if we multiply f of x by 1 over C, meaning that we compress the graph vertically by a factor of C. And if we multiply the constant C to x, meaning that we compress the graph horizontally, so we compress it like this by a factor of C. And if we divide x by C, meaning that we stretch the graph horizontally. For the reflection, for example, if we have C equals to -1, we reflect the graph across x-axis because we take the negative of the value of f of x. But if C is multiplied by x -1, if we have f of minus x, meaning that we reflect the graph across y-axis. For example, okay, you can read this later, but I will illustrate it in here. Say we have So we have f of x is square root of x from this example. And we have g of x is 3 times f of x, and h of x is 1/3 of f of x. We can see here square root of x is the blue one, and 3 times square root of x is the red one. 1/3 of square root of x is the green one. So the red one, we multiply the square root of x by a constant greater than 1, meaning that we stretch the graph vertically. So it is going up. And if we multiply by 1/3, then we compress the graph so it looks like the green one. Now, what if we multiply the x by 3 and divide the x by 3? Now, the difference is that, okay, we have square root of x, the blue one. If we multiply x by 3, meaning that we compress the graph horizontally. So from the blue one becomes the red one. And if we divide x by 3, meaning that we stretch the graph horizontally. So from the blue one becomes the green one. Any question up to this point? Any question? Any question? No? Is it understood, or now you are getting more confused?
Sir,
Yeah.
I'm sorry for interrupt, but I want to ask.
Yeah.
Tadi grafik yang bawah aku belum terlalu mengerti.
This one?
Yeah.
Okay. So we have square root of x. F of x is square root of x, and the graph is the blue one. Now, I want to illustrate this part. So we multiply x by c, or we divide x by c. If we multiply x by c, we compress the graph horizontally. So that's why the graph is previously the graph is this long, from 0 to 10. Now it's only up to from 0 up to around 3.3 here, because we compress it by 3. And if we divide x by 3, meaning that we stretch the graph horizontally. So now previously it was from 0 to 10. Now we have the same value from 0 to 30. Is it clear enough?
Okay, thank you, sir.
Okay. Now the last part that I want to show you is this one. Is the reflection. So what I want to see. Now we take we multiply fx by -1, or we multiply the x by -1. Okay, sorry. -1 times square root of x. Here is square root of -1 times x. Now, in this case, we see that, okay, first we have square root of x, the blue graph. If we multiply square root of x by -1, it is reflected by the x-axis, meaning that we will get the red one. The blue one and the red one, the shape of the red one is exactly the same as the blue one. It's just that we reflect it across x-axis. And if we multiply -1 to x like this, instead of multiplying -1 outside, we try to multiply -1 inside, meaning that we will get a reflection across the y-axis. So we get the green one. For this illustration, is it clear? Any question? No?
I think no, sir.
We have many take-home challenges. Oh, sorry, 5 that you can do at home. Please make sure to try these challenges. Now we go to the next material, which is trigonometric function. Sorry, this for the next 3 slides, they are basically the same as what you learned during high school. So I believe that I can go a little bit faster than before, because before you have not learned about scaling, shifting, reflecting. Now about trigonometric function, exponential functions, and inverse functions, and logarithm. Basically, you have learned them in high school. I will just go a little bit faster in this case. For this part, we only learn about some basics and some challenges. So the basics of this is that, okay, angles are measured in degrees or radians. And I believe during high school, usually you will use degrees instead of radians. Am I correct or am I wrong? So you're familiar with the degrees, or you are more familiar with radians in this case for angles?
Degree, sir.
Degree, right? But let me tell you something. Now, believe me that degrees, angles measured in degrees, we can only use it up to, let's say, a 3-dimensional system. Sorry, we can only use it for 2 or 3-dimensional system. If we go higher, or if we go only like a 1-dimensional system, this degree does not work. That's why in calculus, or from now on, I believe also in chemical engineering, when you go to your 2nd year, 3rd year, 4th year, and if you, for example, if you continue your study to master degree or even up to a doctoral degree, you will use radians more often than degrees. So in this case, I'm saying that the standard scale for angles is actually radian, not degrees. So from now on, make sure that you are used to radians instead of degrees. What is radians? So P radians is basically about 180 degrees. So 1 radian is actually about 180 over P degrees, or approximately 57.3 degrees. And 1 degree is around P over 180 radians, or approximately 0.017 radians. Any questions up to this point? From this course, you have to get more familiar with radians. Okay, any question?
No, I think it's clear, sir.
No? So now what are the basic trigonometric functions that you need to know? There are 6 basically: sine, cosine, tangent, cosecant, secant, and cotangent. What is the definition of sine of theta? Let's consider this unit circle or a circle with a radius of r, and this the angle theta is actually this from x-axis up to this line, the blue line. What is sine of theta? Sine of theta is the number, the magnitude of y over the radius. Cosine theta is x over the radius. Tangent theta is x over y. And cosecant is basically 1 over sine. Secant is basically 1 over cosine, and cotangent is basically 1 over tangent. And I believe you know this from your high school, so let me skip it. And now I will explain you some important formulas. For example, trigonometric identities. We have cosine squared of theta plus sine squared of theta equals 1, and 1 plus tan squared of theta equals secant squared of theta. 1 plus cotangent squared of theta equals cosecant squared of theta. For the second one and the third one, we can actually obtain them from the first one. Let's say if we divide the first one by if we divide the first one, both left-hand side and right-hand side of the equality, by cosine squared of theta, we will get this second identities. If we divide the first identity by sine squared of theta, we will get the third identity. And next, we have the addition formulas, which is like this. So actually, for this addition formula, you already know it from your high school. And from these addition formulas, we can get this double angle formula and half angle formulas. But now I want to explain to you this law of cosine and some 2 special inequalities. So for law of cosine, so from your high school, you have Pythagoras formula. With this angle, this 90-degree angle, and if we have x, y, what is the formula here? Sorry, let's say here is z. What is the Pythagoras formula for this triangle? Z square equals
Y squared plus x squared.
Yeah.
Z squared equals to x squared plus y squared. Now, what happened if we have something more general like this, or something like this? Here is the angle theta, here is the angle theta, and let's say here is R S T R S T. So basically, the law of cosine says that t squared is equal to r squared plus s squared minus 2 times r times s cosine theta. Remember that theta is the angle facing this side, the t. This law of cosine works for both cases or in general for any theta. Let's go to that Pythagoras. So what happened if theta equals to pi over 2, or you know it as 90 degrees? Then we have t squared equals to r squared plus s squared minus 2rs cosine of pi over 2. What is the value of cosine pi over 2?
0.
Miss.
0. Cosine of 90 degrees is 0. In this case, we have t squared equals to r squared plus s squared. Now, take a look at this formula and the Pythagoras plot. Are they the same or are they different? Are they the same or are they different? So here we derive from the law of cosine, where theta is 90 degrees or pi over 2. We get t squared equals r squared plus s squared. And from Pythagoras, we have for this triangle, we have z squared equals x squared plus y squared. So are they the same or are they different? Hello.
The same, sir?
They are the same, right? So if we have theta to be pi over 2 or 90 degrees, then we have exactly the same form of formula, right? We basically get the Pythagoras formula. In this case, we can say that this is the general form of Pythagoras, like this, I think. Yeah. So if you know this law of cosine, you will get Pythagoras formula easily. That's why you need to remember this. So any question up to this point? Any question? No? No? Understood?
Understand, sir.
It's clear. Okay. And next is the two special inequalities. So if we have angle theta measured in radians, the sine and cosine function satisfy these two inequalities. So you don't need to you don't need to, what is the, forgot. You don't need to memorize this two inequalities. You just need to know that this inequalities exist, and if you happen to face these two inequalities, you can just take a look at this slide. Now let's go to the challenge. So, what is the value of cosine x and tangent of x if sine of x is 3/5 and x is in this interval? Sine of x is equals to 3/5 and x is in pi/2 up to pi. What is cosine of x? And what is tangent of x? So this should be easy, but we need to make some picture first. So if x is in this interval from from pi/2 up to pi, in which quadrant does it lies in Cartesian? So if x, or the angle, is from pi/2 up to pi, then we have a triangle in which quadrant? First quadrant, second quadrant. This is first quadrant, second quadrant,
Second quadrant.
third quadrant, or fourth quadrant. So in this case is in second quadrant, right?
Second.
Yeah. Now we simply need to make a picture, a triangle. Since it is in second quadrant, meaning that we will have a triangle that looks like this. Because this is the angle theta, and here sine of x is 3/5. So where should I put 3? Where should I put 5? 3 is in this vertical line or in the horizontal line?
Vertical line.
Vertical. 3 and 5. Where should I put it?
Garis miring, sir.
Garis miring.
Here. Then what is the value of this horizontal line in this case?
-4.
4.
-4. -4, why? Because we go to the left of the half plane. So it is not 4, but -4. In this case, what is the value of cosine x?
-4 per 5.
-4/5. And what is the value of tangent of x?
3/5. Min 4.
So -3/4. Okay. Any questions for this example? No?
I think no, sir.
No. Now let's go to the next challenge. Now we have a cosine of x equals to 1/3. And x is in -pi/2 up to 0. -pi/2 up to 0. What is the value of sine of x, and what is the value of tangent of x? So x in minus pi over 2 up to 0 in which quadrant? First quadrant, second quadrant, third quadrant, or fourth quadrant in this case? The triangle is in quadrant. First, second, third, or fourth quadrant? Fourth quadrant. Because it is from minus pi over 2 up to 0. So now believe me that the triangle should look like this. Now, where should I put the 1 and where should I put 3?
Three di garis miring, sir.
Okay, 3 is here and 1?
Horizontal.
Okay, 1. So what is the value of this vertical line?
2 akar 2.
Basically, this is a square root of 9 minus 1 or a square root of 8, or we can write it as 2 times square root of 2. So what is the value? Oh, sorry. Positive or negative?
Negatif.
Negative.
Negative, right? Because we are going down now. So this should be negative. Then what is the value of sine of x?
2 akar 2 per 3. Negatif.
Minus 2 times square root of 2 over 3. And what is the value of tangent of x?
2 akar 2 per 1. Negatif.
Minus 2 times square root of 2. Okay. Okay, this is correct. Now let's go to the third example. We have now tangent of x equals to half, and x is in pi up to 3 pi over 2. What is the value of sine of x? And what is the value of cosine of x? Now you do it and let me know what is the value of sine of x and what is the value of cosine of x. One minute. Is it enough? So anyone knows what is sine of x?
Can I answer, sir?
Yes, of course.
Saya jawab pakai bahasa Indonesia ya.
Yeah, sure.
Untuk sin x-nya, saya dapat 1 per akar 5.
1 over?
Akar 5.
Square root of 5. And what is cosine of x?
2 per akar 5.
2 over square root of
Yes.
5. That
Yes.
is Rianti's answer. Anyone object this answer? Anyone have an objection to this answer?
Same answer, but I add negative.
Okay, based on Jason, this should be negative. Why, Jason?
Because itu di bagian ketiga. Jadi untuk horizontal sama vertikalnya negatif. Kenapa
Okay,
tannya nggak
because it
negatif?
is
Karena atas bawahnya negatif, jadi positif.
This is in third quadrant. That's why the triangle should look like this. So it should be here -1 and here -2, right? And here is the square root of 5. That's why the value of sine of x and the value of cosine of x are both negative. So Rianti, you almost almost got the correct answer, but please be attentive to this interval. Okay. Just be more attentive to this interval. Any questions up to this point?
I think no, sir.
No. No. Is it clear enough? Now I'm going to the next challenge. We are asked to graph this function and determine its period. I'm helping you answer this challenge. So the function is f of x equals sine of 2 times x. Okay. So if we plot it from 0 to 4 pi, we have the plot that looks like this. Some things that repeat itself over some interval. So after some interval, the plot of sine of 2x repeat itself over and over again. And this kind of function is called the periodic function. Why? Because they repeat themselves over a certain interval. In this case, after pi interval. So from 0 to pi, the plot looks like this. Go up, down, and back to 0. And then pi to 2 pi, it repeats the same form. So from 0 up and down and return to 0 again and again. This kind of function is called periodic function. In that case, it has a period. So can anyone guess what is the period of this periodic function? So the period is we can say that the period is the time or interval or the length of an interval for which the graph repeat itself. So in this plot, after what is the length of interval for each plot? I already divide them by this dashed line. You can already see what is the length of each interval. What is the length of each interval in this case?
I don't know, sir.
From 0 to pi, what is the length from 0 to pi? The distance between 0 and pi. What is the distance between 0 and pi?
Wait. Jawabnya dengan cara apa ini, sir?
So if we have a point at 0 and we have a point at pi, what is the distance or the length between 0 and pi?
180 degrees.
Or pi, right?
Yeah, a pi.
And what is the distance from pi to 2 pi?
A pi also.
Also pi. And from 2 pi to 3 pi, what is the distance from 2 pi to 3 pi?
A pi also.
Also pi. And how about the last one from 3 pi to 4 pi?
4 pi also.
Okay. Now, let me remind you that this blue curves that goes up and down, up and down, up and down, is the curve of sine 2x. So the curve of this function. And as we see that after pi interval, it always repeats itself, right?
Yeah.
Yes,
Right?
sir.
It always repeats itself. In this case, since the graph repeats itself after certain interval, we call it a periodic function because it repeats itself periodically, and the period is basically the length of the interval for which the graph repeat itself. So in this case, the graph repeat itself after pi interval. So in this case, the period is pi. Understood?
Yes, sir.
So now my question is, this example. Let me graph it first. Now the function is cosine of x minus e over 2. And I think I don't need this and I don't need this. So the plot looks like this. So this is the plot of cosine of x minus pi over 2. In this case, what is the period of this function? What is the period?
Two pi.
2 pi. That is correct. So anyone have any questions up to this point before I move to the next materials? Any question?
Understand, sir.
Hope that you don't ask because you understand, okay? So there are some challenges that you can do. There are only 3. Now we move to the next material, which is about exponential functions. So, same thing, we only learn the basic and then some challenges, and we move to the next material. So, for example, if we have a quantity P, so let's say we save our money in a bank, in the banks, or we invest some money to a company, and we know that our investment will double after, let's say, a certain time. So it will always double after, let's say, 10 years. Then this investment P, after 10 years, it becomes 2 times P. And then 10 years later, it doubles again. It becomes 2 times 2 times P. So we have 2 squared P. At the 30th year, we have, so after the next 10 year, it doubles again. It becomes 2 times 2 squared P. We have 2 cubed P, and so on. So we see here that we have a a certain number powered by something. In this case, we can consider a function that looks like this. F of x equals 2 power x. This kind of function is called exponential function. And 2, in this case, 2 is called the base of the exponential function, and x is the independent variable. So in general, if a is not equal to 1 and a is a positive constant, a is not equal to 1 and a is positive, then this function, this kind of function, f of x equals a power x, is called the exponential function with base a. I believe that you already know this from your high school. So let's go to the rules for exponents that you need to know. If we have a positive and b positive. Now, please remember that we treat a and b here as the base. Then we get these following rules. We know that the following rules true. Sorry, this is not correct. Following rules hold for all real number x and y. Meaning that, okay, if we have a exponent, this a power x times a power y. So the base are the same. The base are a. Then in this case, we can make it equals to a power x plus y. And if we do this quotient, we have the power is subtracted. So we take the difference of the power. So whatever is below the division, whatever becomes the denominator, the power is negative. And if we have a power x and then we power it by y, it is equals to a power y powered again by x. So we can flip the position of x and y. And we have a equals to x, equals to a power x times y. And what happens if the base are different, but the power are the same? Then we can make it like this. So a power x times b power x equals to a times b power x. And if we have the quotient, we also have this rules. Let's take a look at this illustration. For the first one, we have the same base, 3, but different power. The first one is power 1, 1. And the second one is 0.7. So we have this equals to 3 power 1.1 plus 0.7 is equals to 3 power 1.8. So in this case, we know that 3 power 1.8 can be written also in this form. This is from the first rule of exponent, from this first rule. For the second rule, because we have quotient, then the power is now subtracted. We take the difference like this here, and we get this. And what happens if we have power and then power it again? Then the power is multiplied. And if the base is different but the power is the same, we have this operation. And if the base is divided and we have the same power, we also have this operation like this. Any questions up to this point?
No, sir.
No? Okay. Example. So suppose that we own an investment company. Then investment company often use this kind of model. Y equals to P times E power R T. Do you know what this E stands for? Anyone knows? I think you already learned about this number E from your high school, but I don't know if all of you still remember it. Anyone forget about this number E? You can let me know, it's okay. Or all of you remember this number E?
I don't know, sir.
Don't know? Okay, maybe you forgot. You should have learned about it in your high school, but okay, let me tell you this. The constant E, we usually use a constant symbol E as the Euler's number. Euler, since he is a German, we we write EU as Euler number. So we have this. This E is actually Euler's number, and it is actually this kind of number. This kind of number. So 1 plus 1 over 1 plus 1 over 2 factorial plus 1 over 3 factorial and so on, up to 1 over infinity factorial. And approximately the value of Euler number is around 2.71828 and so on. So now you know what is E. You already know what is pi. What is the value of pi? The approximate value of pi? What is the approximate value of pi? Anyone remember?
3.14.
Yeah, it is around 3.14. And the approximate value of this number E is this one. So around 2.72. Now, anyone of you still confused about this number E? Why it disappears? As you see, this number E appears in the function of calculating growth of an investment. So this number E also appears in economic studies or accounting. And I believe that in chemical engineering, you will see a lot of E later. So for now, believe me that this E will appear everywhere in your life. And believe me that this equation is correct for calculating growth of an investment. So suppose that we first invested $100 in 2014 at an annual interest rate of 5.5%. So basically, after 1 year, we get about 5.5% of this from our first investment. So now in this case, we let t equals 0 represent the year 2014. So let's say t equals 0 is the year 2014. It means that t equals 1 is to the year 2015 and so on. So what do we do if we want to predict the amount of our investment in 2018? So first we put in all the value. First investment is $100, meaning that P is equals to 100. That is the initial investment. And the annual interest rate is 5.5%, meaning that the constant R is 0.055, because we need to convert this 5.5% to a decimal. And we consider t here in this equation as time in years. So if we want to predict the amount of our investment in 2018, we need to see what is the value of t in that case. So if in 2014 t is equal to 0, in that case, since there are 4 years of difference between 2014 to 2018, then in that case we have t equals to 4. So we can compute this y of 4 equals to this. So approximately after 4 years, in 2018, our money will grow from $100 to 124.61 US dollar. For this example, any question? Is it clear enough, or? Okay, any question? Is it clear enough?
I think it's clear for me, sir.
For the others?
It's clear for me too, sir.
Clear, sir.
We are asked to sketch this graph. Y equals to 2 power x, and y equals to 4 power x, y equals to 3 power minus x, and y equals to 1/5 power x. For this challenge, I already prepared the graph. Actually, the graph is like this. So 2 power x is the blue one, 4 power x is the red one, 3 power minus x is the green one, and 1/5 power x is the purple one. Can you see the difference? Can you tell me what is the difference between all the plots, all the functions? Which one is growing? Which one is increasing from the bottom left side to upper right side? And which one is decreasing from the upper left side to bottom right side?
The red and the purple one.
The red and purple one is increasing or decreasing?
The red one is increasing, the purple one is decreasing.
Okay, the red one is increasing and the purple one is decreasing. Can you notice what is the difference between the two of them? So let's see at the base. The red one, the base is 4, meaning that the base is more than 1. If the base is greater than 1, we have increasing function. But if the base is between 0 and 1, we have decreasing function, because the purple one is 1/5 power x, right? What about the green one? 3 power minus x. Why it is also decreasing?
Because it powered with minus x.
And we can actually, in this case, we can make it to 1/3 power x, right? So y equals to 3 power minus x is actually equals to 3 power minus 1 power x, or equals to 1/3 power x, right?
Yep.
And this part is between, sorry, there's no equal, so between 0 and 1. So we see here that if the base is between 0 and 1, we have a decreasing exponential function. And if the base is greater than 1, we have increasing exponential function. Clear? Is it clear?
Yes, sir.
Oh. How to sketch this graph? I will give you the answer. So we have y equals minus 2 power t and y equals to minus 2 power minus t. Oh, sorry. 2 power t and minus 2 power t and 2 power minus t. So let's have this function as our base. Y equals to 2 power t. Now, if we plot it in the Cartesian diagram, we have in the Cartesian coordinate, we have this t and this is y. And for the basis function, we have y equals to 2 power t, meaning that we have something. This is y equals to 2 power t, and it crossed the y-axis at 1. Okay. Now, let's take a look at this. Y equals to minus 2 power t. So we have the graph of 2 power t. If we multiply 2 power t with negative, what happens to the graph of 2 power t? Is it a shifting, a scaling, reflecting? Which one? Shifting, scaling, or reflecting? If we multiply by negative, is it shifting, scaling, or negative? Or reflecting? Anyone remember? If we multiply by minus 1, it is a reflection. Okay. So if we multiply 2 power t by minus 1, is it a reflection about across the t-axis or across the y-axis?
Pardon me, sir?
So if we multiply 2 power t by minus 1, is it a reflection across the t-axis or across the y-axis?
Across the y-axis.
Let's check. Okay, here. So if we multiply fx by minus 1, in this case, reflect the graph across the x-axis. So in this case, the graph of y equals to minus 2 power t, it is the reflection of y equals 2 power t across t-axis or y-axis. So we have this 2 power t and then minus. Here, which one? The top one or the bottom one? one or the bottom one? Hello.
Yes, sir.
So now back to this question. Is this a reflection of 2 power t across the t-axis or the y-axis?
The t-axis.
This is a reflection across the t-axis, basically. So here is -1, and we have the plot of y equals to -2 power t. Now, what if we put the negative in the multiply -1 to the independent variable? In this case, we have a reflection across the y-axis, so it should look like this. So here we have y equals to 2 power minus t. Understood?
Yes,
Yes,
sir.
sir.
Now, for this graph, you can try it by yourself at home, and also for this graph. Okay, so let me plot it here. So we have here the plot of e power x, the green one, and we try to multiply e power x by -1. That's why we reflect it by the x-axis. So we get the blue plot. So this is the plot of minus e power x. And if minus e power x, we multiply -1 on x, then meaning that we reflect it again across the y-axis. So we have the red plot. So this y equals to minus e power x is the blue plot, and y equals to minus e power minus x is the red plot. That is basically how to plot it. Okay. And you can also try this by yourself at home, because here we have shifting, and here we have a reflection and then shift. Any question for this part of the materials? Any question? You can ask. And you can always, as I said before, you can always interrupt me whenever you feel that I'm too fast or too slow or whatever. Any question? No?
No, from me, no.
No, saya paham.
Then
Sir,
now, yeah.
I think no, sir.
is my voice clear,
Yeah,
sir?
Tega. Yeah.
Gini, sir, kalau misalnya ujian nanti, apa bakal ada grafik juga, sir?
Maybe.
Berarti kami harus buat grafiknya, sir?
Yeah, but it will not be a complicated graph. So you should be fine with that.
Okay, sir. Thank you.
So you can complain to me if the graph that I mean, if the question is about graphing about some function that is very, very complicated, you can complain to me. I will try to, if it is about graphing, I will try to give you graphing that is not that complicated. For example, the graph of x squared, the graph of square root of x, the graph of line function, the graph of sine function, which you already familiar with. That kind of graph that I will give to you, not the more complicated one. No. Okay, now the last part of this morning session is about inverse function and logarithm, but I don't know if I will manage to finish it. If we don't manage to finish it, we will continue about it later after in the next in the afternoon session. So the third part is about inverse function and logarithm, and I think I can go a little bit fast, but I think I can go a little bit fast in the inverse function, logarithmic function, and inverse trigonometric function, but not for the first one. So please note, please pay attention more to this first part. So one-to-one function. What is a one-to-one? One-to-one function is basically a function f is one-to-one on a domain D if f of x1 is not equal to f of x2 whenever x is not equal to whenever x1 is not equal to x2 in D. What is the example of one-to-one function? It is like this plot. Okay. Let's plot sine 2x from 0 to pi. In this case, this is not a one-to-one function. Why? Because when we have, for example, x equal to 0, x equal to pi over 2, and x equal to pi, we have the value of sine 2x are the same. They are 0, 0, and 0. So in this case, we have the same value fx, but different x. In this case, this function is not a one-to-one. But what happens if we restrict the interval only up to pi over 4? So we restrict the interval only up to pi over 4, then we get a plot like this. In this interval, there is no one fx that have there is no one fx that has that have two different x. In this case, we can say that f of x equals to sine 2x over the interval from 0 to pi over 4 is a one-to-one function. Is it clear? So basically, a one-to-one function is in that domain. We cannot have two different. We cannot have two different x that maps to the same value of f. So that is basically a one-to-one function. The illustration is like this. So if this one is not one-to-one, because for different, so let's say if we take a look at this f of x equal to 0.5. This can plot 0.5 from 0 to pi. Legend. And And find style dash. Okay. G of x is equal to this is G. Here we see that in this dashed line, so if we have a horizontal line like this, the horizontal line intersects the blue curves at least 2 times. In this case, in this domain from 0 to pi, this function is not one-to-one. But if we restrict the interval only from 0 to pi over 4, the dashed line here only intersect the blue curve one time. In this case, even if we shift the dashed line from down up to 1, the dashed line is always intersecting the blue curves one time. In that case, in this interval, we say that sine of 2x is 1-to-1. Is it clear or not? Is it clear?
Clear, sir.
Clear? Okay. So, for example, f of x equals to square root of x is 1-to-1 on any domain of non-negative numbers, because square root of x1 is always not equal to square root of x2 whenever x1 not equal to x2. But sin of x is not 1-to-1 on the interval 0 to pi, because sin pi over 6 is equal to sin 5 pi over 6. But if we restrict the interval to only from 0 to pi over 2, for this case, the function g of x equal to sine x is 1-to-1. So we can use a horizontal line test for 1-to-1 function, like what I illustrated earlier, like this one. So if all the horizontal line only intersect the graph one time, exactly one time, then or at most one time, then the function is 1-to-1. So now, challenge. This graph is 1-to-1 or not? Is it 1-to-1 or not?
Sir, can
Yeah.
I answer that? I think 1-to-1.
That is correct. That is correct answer. Good job. So we have the blue curve is 1-to-1, because if we draw a horizontal line from the bottom to up, if we shift the horizontal line from the bottom to the top, we always the horizontal line always only intersect the blue line by at most one time. Is it 1-to-1 or not?
I think not, sir.
No, yeah, that is correct. So this one is not 1-to-1. This one, 1-to-1 or not?
Sir,
Yeah,
I think not, sir.
no, yeah, that is correct. So this function is also not 1-to-1. And what about this function? Is it 1-to-1 or not? Is it one-to-one or not?
Yes, is it?
Yes. Yeah. This one is a one-to-one function, because if we draw a horizontal line from the bottom to the top, it will never intersect the blue line more than one time. Okay, the last challenge. Is it one-to-one or not?
One-to-one, sir.
Yeah, this one is also one-to-one. That is correct. So, any question up to this point for this first part? The question? No? Okay. Then there is this final challenge. This graph, this function, is it one-to-one or not? Is it one-to-one or not, the function? Is it one-to-one or not? Okay, let me draw.
No.
No, why? This is
Wait.
not one-to-one, why? And if it is one-to-one, why? So f(x) is x less than 0. If yes, then 3 minus x. 3. Plot f from, let's say, minus 5 to 5. The plot is like this. From this graph, okay, let's just plot it from minus 2 to 2. From this graph, is it one-to-one or not? Is it one-to-one or not? This should be easy. One of you already answered that this is not one-to-one, but the question is why? Why? Okay, let's use the horizontal line test. If we take this one horizontal line, from minus 2 to 2 line style dash. So from this horizontal line test, we can actually see why it is not one-to-one. Because if we take a horizontal line at y equals to 3, then we have that when x is positive, the horizontal line intersect the function f of x infinitely many times. So it is actually the same line. So this is why f of x in this case is not 1-to-1. But my next question is, can we make this function f of x 1-to-1? How to make it 1-to-1? It is actually quite clear from this picture. It is similar to the sine function. How to make sine function 1-to-1? We restrict the interval. So this function, we can make it 1-to-1 if we restrict the interval where? Where? Anyone knows?
The first interval.
Okay, so if we restrict the interval to be from -infinity to 0, then the function is 1-to-1, correct?
Yeah.
Yes, sir.
Good. Now I already take like 13 minutes of your time. We will continue after we will continue in the afternoon session for this next part and for the next slides. So I'm sorry for taking up extra of your time. Let's see you again after. See you again in the afternoon. For this morning session, I will end it now. Good morning and assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you so much, sir.
Thank you,
Thank you,
sir.
sir.